Three, two, one. All right, folks. So as we said in the last video, we're going to get started with the template that we started for everyone, or we created for everyone. So for this particular situation, I'm going to have it side by side. So my console is here, assuming that everyone on a Windows machine specifically is using the same setup from the install videos. But everyone at this point should be on a Linux type of machine to get started, because you're going to need that in order to interface with some of the blockchain steps. So to get started, first things first, assuming that everyone has followed and is all good with the setup, we should be able to go ahead and say git clone. Let me make this a little bit bigger. So we'll say git space clone space. Well, yeah, space. And then we'll paste in, to make this a little bit easier for everyone to see, we'll go up here to this green code area, click that, and then you should get the same URL that you have down here, right here. So we'll make sure that that's the same thing. So GitHub coding simple blockchain capstone full.git. That should be the same thing down here. So I'll go ahead and copy that and I'll paste it in. If you want to paste this inside of your terminal on your mouse, you want to right click and that will give you that. And then we'll go ahead and space and we'll call this CT capstone. All right. This is going to ask me for my GitHub account because it's been a while since I've been on this side of things. So we'll say, okay, so I had to switch over to my Windows side of things because I have everything set up for Git on that side of the house. So when I tried to do this on the other side, this is what I got because I didn't set up everything on my Linux side of things just yet. So I'm going to use the Windows, but for those that are on the Linux side of the house, it's going to be the exact same step. Just making sure that I don't have to put my password in because I don't remember it off the top of my head. So we're going to say clone, git clone, and then paste in that HTML or HTTPS link that we got from GitHub. And then we'll say we want to create a CT capstone, unless they already did it. Nope, didn't do it yet. There we go. So we'll go ahead and CD into CT capstone. And there we go. We should be able to get started from here. So I'm going to switch back over to my Linux side of things because everything that we need to do is going to be mostly on the Linux side. So I'm going to switch over now. Okay, so we're here now and we have everything in or at least downloaded so that we can start the install process. The first thing that we're going to need to do after CDing into the proper channel. So again, to do that, let me just back up so everyone is familiar with that. But we'll want to do a CD and then the project name. So that will literally be CD space CT capstone. And I'm already in that directory currently right now. The magic of editing put me there already, but I'm already here. So CT underscore capstone is where you want to be. Sorry about the spacing. I just wanted to make sure this is big enough for everyone to see. But after you do that, then your next step will be to install everything. So we'll say npm install, or as it says over in the instructions, you can also use yarn if you have that installed as well. But we'll say npm install because that should be universal for everyone. And that should get us started with the things that we're going to need for the project to get started with. This is going to take a little bit of time, so I'm going to let this run and I will see you on the other side after this is done. Okay, folks, so we are back and we now have all of our dependencies correctly installed. So if you got down here and installed everything correctly, you should now see this guy right here. And from here, we should be able to go ahead and get started. So this next thing that we're going to need to do is create our smart contract, which is basically going to be the communication between us, our front end, and the blockchain. So let's go ahead and get started. All right, so let's go ahead and create our contract. To do that, we'll want to head into Visual Studio Code. So if you have not installed that, you want to go ahead and install that first. But I'm going to use a shortcut code inside of inside of the terminal to open Visual Studio Code easier for me. So I'll go ahead and say code space period, and that should go ahead and open the, it did it off screen. So let's do it right here. And there we go. So now we have all of the information that we will need for our contract to kind of get the lay of the land of what's going on inside of this project as a whole. What we have here is the building blocks of a network, or a test network, as it were. And we got that information because of this guy. So if we go back over to our browser, go back to the project, I'll go here. And if we go to Truffle, I think, make sure I got that right. It's actually in the, let's just use here. I'll make sure I got that URL right. Yeah, there we go. So Truffle is the package or the framework that we use to build full stack web development or full stack Web3 projects when we talk about the blockchain specifically. So here we have a bunch of things that we can do that allow it a lot of flexibility to do blockchain development with a front end, and more specifically with a React front end. So a lot of this is already created for us. We could also, if we go to their official docs, and I'm trying to look for that link right now, but I don't see it. So let's go to the official docs, Truffle docs. Let's see if we can find that really quick. There we go, Truffle Suite. And if we take a look here, we get a lot of good stuff. So we have Ganache, which we have already installed right now, which gives us a one-click blockchain. Also Truffle, which is the thing that we are using right now. And inside of it, we have the ability to create migrations from the contracts that we write and all that good stuff. If we look inside of this, we can also do some testing inside of our smart contract based on this framework. All of that is already given to us, and let's take a look at the boxes that they have already as well. So this is also coming from a lot of the stuff that we saw inside of here. So if we go back, a lot of that is coming from here. So it's basically built on top of these bundles that we already had, and then I just kind of added on what we needed from there. So created a box, added it, then added it to GitHub. So without further ado, let's go ahead and create our first contract. So if we go back to here, we'll want to do that inside of this contract here, and you can see that we have a store contract file and a migrations contract file. We're going to rename this store to Comic Store in a second, but just I wasn't sure when we started which type of store we were going to use, so I just kept it very general. So in this case, migrations, this is basically giving us the ability to start a migration and then push that forward to whatever network we want to use. But that network is going to be constructed by all of this good information here. So specifically, when we actually are ready to deploy our contract, we'll go ahead and say, hey, inside of our terminal, specify what type of information or where we want to send our project to after we're done creating it. Obviously, we aren't there yet, but when we are, we'll go ahead and say, hey, based on the networks that I have listed here, use this one. And we're going to have to change this network because it's now deprecated as of the time of recording this. It wasn't when I first started it, but it now is, since Ethereum 2.0 has now been released. So now we're going to change this later, but for the time being, this is the network that we would be using. So the name of the network, the provider, which in our case is going to need a secret key and a endpoint URL, a network, how much gas we are willing to pay, confirmations after we do this. So we're looking for 2 confirmations. How long is the timeout after we're done? And then we're going to skip the dry run because we don't really need that at all. Where can we find our contracts? Well, that is going to be inside of the contracts folder. And where can we find the build of our contracts? Well, that will be found inside of shared/ABIs, which is going to be inside of source, which is right here. That's not created just yet, but once we actually go ahead and deploy this, it will be created on the fly down inside of here with the names of the contracts that we created earlier. Then from there, we'll just say, hey, which compiler do we want to use here? And so in this case, we can say whichever version we decide to use. So we can, without much certainty, or I'm sorry, with much certainty, we can specify which version we want based on the versions that we have inside of our smart contract. So without, and I'm sorry for saying this one more time, but this time I mean it, we're going to actually start building the contract. So let's start with that and get that out of the way. So first things first, remember, we need to specify what kind of license we want. So in our case, we want to use the same one that we were using before. So I'm just going to copy and paste that from before. So I'm literally copying that from off screen from a different contract that we were using before, excuse me. And then underneath that, we're going to use Pragma Solidity. And then we'll say caret 0.8. I think we're on 15 at this point. So we should be good there. Okay. So we'll start with contract. And the contract is going to be called Comic Store. And since we're going to use Comic Store, we're going to also change that to Comic Store here. Comic Store. Cool. All right. So the first things that we want to do will be defining some store variables. And more specifically, these will be known as state variables inside of our smart contract. So the first thing that we want is an address, which will be public and immutable because we don't want that to be changed on the fly. So store owner. Then we will do a uint, and we're going to get some errors up top there because we don't have a constructor, so that's fine. But we'll say public store, I'll just say ACC for short. We'll then say string public store name uint 256, which we could use that as uint by itself, but we'll make it explicit. And we'll also make this immutable. And this will be the fee percent. We can also, let's call that tax, just to make it easier, tax percent. Okay. And then last but not least, we will do a uint 256 public store sales. Cool. All right. So our state variables out of the way, let's go ahead and track some users. So tracking users, or set up the mapping for tracking users. So tracking users number of sales, and we'll say mapping address uint 256, and that is not going to be that. Sorry about that. Uint 256 will be public, and sales of. That's what we're going to call it. Okay. So from here, we will then further declare some more event information. So we need to talk to the outside world from our contract. So we'll say declaring events within each sale. Event sale. And we're going to space this out a little bit so we can actually see how this works, or see it a little bit easier to read. So we'll say address indexed buyer, because we want to make sure that is indexed based on when the sale is done. We'll then say address indexed seller. Uint 256, which will be amount. And uint 256, which will be the timestamp here. All right. So from there, we'll say event and withdraw. Draw. Yeah. And we'll say address indexed receiver. Uint 256, not indexed, so amount. And we'll then do uint timestamp. Cool. And that should be uint 256. But again, that could be just uint as well, and it will still work. Okay. So we got our events. So when a sale happens, we can see what happened inside of that. Let me take this out of here. And I do believe I need a semicolon. Yeah, I'm missing a semicolon there and here. Okay. Clean that up. Okay. So now that we have that, what's going on? So what's going to happen is once we send out or make a sale of some sort, what's going to happen is an event is going to be emitted about that sale, and a withdrawal will be emitted, or a withdrawal event will be emitted as well about the impending sale once it's obviously done. So from here, we can go ahead and set up a sales structure so we can actually look at what the address of the buyer, the address of the seller, and all the pertinent information that we need to get from that sale. So we'll say structuring the sales object. And this will be struct sales struct. And we'll get address, which will be buyer. We'll then have an address for the seller. We'll have a uint for the amount, uint 256. Again, that could be by itself, but we'll make it explicit. String purpose of sale. And one last thing, uint 256 for the timestamp. Alrighty. So with that sales structure created, let's go ahead and use it for the very first time. What we're going to be using is sales struct as an array, and we're going to just call it sales. So this is setting the placeholder for it. We don't have any initial value inside of there yet, but we will later on. Okay, so to clear up this error up here, let's go ahead and give this a constructor. So we'll say initialize the store. initializing the comic store. And we'll say constructor is going to be, and I'm going to space this out as well so it's easier to read. You don't have to, but it's just a little bit easier. We'll say string memory because we want to place that inside the smart contracts memory. And we want to say that this is going to be an internal store name. So we'll just say store name here, or underscore store name. Sorry about that. Then from here, we'll say address, which will be store owner. And then uint 256, which will be fee, or we call that, we called it something different this time. I think just for, yeah, tax percent. Okay, tax percent. Cool. Awesome. So with that, now we can actually give that some initial values. So we'll say the store name, or initialize those values when we actually create them. Store name will be underscore store name. And then store owner will be underscore store owner. And we'll do tax percent. Keep that lowercase, tax percent. It's going to be equal to underscore. Did I not do underscore? Yeah, I did. Tax percent. And then last but not least, we'll say store account is going to be initially set to 0 because we won't have one at all, at least for right now. And let's see what's going on here. Did you mean tax percent? Or, oh, I did mean that. Okay. Let's do tax percent. Okay, cool. There we go. So because I uppercased it up here, it also has to be uppercased down here when we go ahead and initialize that with the constructor for the first time. All righty. So everything at this point is constructed in terms of what we will need for holding information, storing that information, and where it will all go. But now we need to be able to do stuff with that information, and specifically be able to pay with the smart contract, send that information to the right person with the smart contract, and then being able to withdraw that money to the person, and then check all sales as well. So there's 4 things that we need to do. Again, just so everyone knows what's coming up. First thing that we want to do is be able to pay now. So we're going to have a function to allow us to pay now. We're also going to have a function that will allow us to pay to someone. So send funds to someone. And then last but not, or second to last, I'll say, will be withdrawing those funds. So withdraw money to, and this is going to send funds to an account. So we're going to find out who to send, who are we communicating to send information to, and then once we figure that out, how do we make sure that that account gets updated with that money? And then last but not least, we will get all sales as well. Cool. So let's go ahead and build these functions, the first of which will be the pay now function. So we'll first say that we want to perform sales payment, which will be function pay now address seller, which is going to be a string of memory, and we'll say purpose of sale. This is going to be public, so I'm going to put this on another line so it's a little bit easier to see because it's going to be a lot to write here. So I'm going to put this on another line and then indent. It's not going to hurt anything. So if you're coming from a Python background with the indentations breaking things, don't worry. So we'll say public to make sure that this is available everywhere. We'll also say this is payable as well. And we will then return or returns a Boolean value. So success. If everything comes back successfully, then we will say success. Cool. Okay, so now we have that. Let's go ahead and validate. So let's start by validating payments. Validating payments. Payments. And we will require a few things. So require that we get the message dot value, and that is greater than 0 because we can't have anything that's free here. So we'll say ethers cannot be 0. Okay. And then one more require. So we'll say require that the sender, so the message sender is not equal to the store owner, because obviously you can't sell your own merchandise. So sell not allowed. All right. Make sure we are lined up here. I think we are. Cool. Then from here, we'll say calculating the cost and tax fees. Cool. So we'll say uint 256 is equal to fee, and we'll say we want msg.value divided by 100, which is then going to be multiplied by the tax percent. Say we call that tax percent, correct? Yeah. Okay. Let's see, what are you warning me about? Unused local variable. Okay, yeah, we haven't used it yet, so that's fine. Uint 256 cost is equal to no parentheses here, so msg.value instead. Excuse me. Minus the fee that we just created. Alrighty, so that is the first portion of that. Now we need to assigning the sales. So assigning sales and payment to the store and product owner. Okay. So from here, we'll say store account is going to be added to, or the msg.value or message.value is going to be added to store account. Store sales will be plus equal added to, or add by 1. And then sales of, which is, by the way, the seller, which is the mapping that we created up above, plus equal 1. All right. Next will be caching out to sales party. So we want to send the information that we are going to get in terms of ethers to the person that is deserving of that information. So we'll say withdraw money to, and this is a function that we're going to create in a second, store owner and fee. Okay. And we'll say the same thing, withdraw money to seller and the cost. So whatever the cost was, send that to the seller, and we should almost be done. We're going to get some errors because we don't have those functions just yet. We want to also record the sale inside the smart contract. So we'll say record sales in smart contract. And that's going to be an array. So we'll say sales.push. And I'm going to put this on a separate line just so it is easier to read. And we'll say sales struct, which is going to have a sender, msg.sender, the seller of who sold the item, the cost of how much it cost, the purpose of the sale, and the blockchain timestamp. So block.timestamp. That's how we get access to that. And that should end with a semicolon there. And we are at the end, almost at the end of this function. So we'll say captures sales data on event. So once an event is sent out, we'll say emit sale msg.sender seller cost and the timestamp. So block.timestamp. Return when that actually happens, true. All right. So now let's finish off these two. So we need to create a function in a second for that. So that should end. Let me just make sure that's ending. Okay. So if you place your cursor at the line of 88 and then hit the enter button twice, you should go down twice. We're going to create another function and we'll say sends ether or ethers to a specific address, specified address. Okay. And that specified address will be created on the fly. So we'll say function underscore pay to. This underscore is denoting that this is an internal function. So this is not going to be externally facing. So obviously we don't want that to happen because we don't want to send information to the wrong person. So we'll say to uint 256 and the amount. By the way, this is a convention underscoring that to denote that this is internal. Then from here, we'll say bool success, and that we'll just do success 1. Cool. And that is going to be equal to payable to. So we're sending who this is payable to, and we're going to call the value. So we'll say value is equal to the amount. Yeah, underscore amount. Cool. Yes. And that should end with a I see what I did wrong here. Let's do curly brace and curly brace. And that should be amount there. Okay, cool. And then from here, we'll say we don't really have anything to say, no message to send back. So let's just say, cool, that's enough. That's all we need to know. And we'll just say stop, basically. So require success. Okay, so that is pretty much it. As long as we have a successful transaction, then we can use this pay to function. But if we don't have a successful transaction, this never goes to anyone. So that's the fail-safe that we are putting into our code, which is, again, the main reason why a smart contract is so useful. So from here, let's go ahead and make sure that everything is closed off successfully. It is. So at line 94, we'll go ahead and drop down twice. And we'll go ahead and create the withdraw money to function. So performs ethers transfer. And we'll say function withdraw money to address receiver uint 256 amount. Notice that this is not prefixed with a underscore. So this is something that we're going to be sharing around the entirety of this smart contract, or inside of the function inside the smart contract specifically. But this is an internal function as well. So we only want this information to go to the person that it's supposed to go to. But let me backtrack here. That's supposed to go right here. Sorry about that. Okay, so that is internal. Now that we have that successfully created, one more thing that we need is a returns. So what are we going to do once this is finished? So bool success is what's going to happen. So we're going to return a Boolean when that actually successfully comes back to us. And we're going to require some things from this function. So we'll say require that the store account is less than or equal to the amount. So basically what we're saying is if the store account is less than or equal to the amount, then what we need to say is we have insufficient funds. Okay. So if they don't have enough money in the account to withdraw, then we shouldn't allow them to withdraw and just say insufficient funds. However, if that does, if we actually do have enough money to draw out, then we will say receiver, and the amount is going to get sent to the pay to function. And let me make sure I close this out. Yeah, there we go. Semicolons are going to be everywhere. Store account, by the way, will be assigned or negatively assigned with the amount. So each time that we add to the store account, we are going to decrement with that amount. Then from here, we will captures transfer data on event. And we will then say emit withdraw. Make sure I spell that right. Withdrawal, receiver, amount, block dot timestamp. Cool. And we will then return true. All right. That's I think that's enough for that function. And the final function that we need to create for our smart contract is going to be one to see or get all of the sales. So we'll say retrieves all processed sales from smart contract. Okie dokie. So function get all sales, which will not have anything in it. And it's going to be a public function that's going to be viewable. And we are going to returns sales struct, which is a array, which is going to be placed inside of the smart contract's memory. And then from here, we will do a return of sales. Okay, that's it. That is pretty much it. That's all we needed for our smart contract. So at this point, we have a smart contract that we can deploy. But let's talk about how to set up everything in terms of the deployment process. And we're going to do that in the next video. So now that we have the contract created, let's go ahead and deploy it. So I'll see you in the next video.